to lecture 11. Today we will explore electrical issues like short to ground, high resistance, and basics of Ohm's law. First, let's talk about a short to ground, which happens when current bypasses part of the circuit and flows directly to ground, like vehicle frame or body. This can cause a fuse to blow since a direct path to ground has little resistance, leading to high current flow. Imagine if someone puts a penny in a car's cigarette lighter, the current would flow through the penny directly to ground, bypassing the circuit load and causing the fuse to blow. Now, understanding the high resistance. High resistance in a circuit can lead to reduced performance. This can happen due to corrosion, loose connections, or poor terminal contact, causing devices like lights or motors to work slowly or dimly. If a car battery terminals is corroded, the high resistance make it hard for current to flow freely, slowing down functions like the engine cranking. Think of a high resistance like a water flowing over a water wheel. The water representing the current turns the wheel using energy that is a potential energy. Just as water reaches the bottom with less energy, electricity loses voltage as it flows through the circuit resistance. This is like how current flows in a circuit, performing work as it moves, but returning to battery with lower voltage. Now, as the water flows over the wheel, it loses energy, similar to voltage in a circuit. The rate flow of water, like the current in amperes, stays the same. The pressure or the voltage drops as work is done, like turning the wheel. Take an example of a car headlight. The car headlight circuit may cause the same amount of current, but the voltage drop across the circuit at its power delight. Coming on to next important concept is the Ohm's law. Ohm's law connect voltage, that is in volts, current in amperes, and resistance in ohm in a circuit. According to Ohm's law, it takes 1 volt to push 1 ampere through a 1 ohm of resistance. If you double the voltage, the current doubles. As long as the resistance remains the same, these relationships helps us to understand and predict how the circuit behaves. The another important applications of Ohm's law is in obtaining the values of unknown quantities in a circuit. We can use Ohm's law to find any one of the 3 values, that is voltage, current, or resistance. If we know the other 2 values, we can get the third unknown value. The formula for this current is equal to voltage divided by resistance. Formula for resistance is equal to voltage divided by current, and the formula for voltage is current multiplied by resistance. Now let's apply this Ohm's law to a simple circuit. With a 12-volt battery which is connected to 4 ohm resistance, we can calculate the current using the formula I is equal to E by R. Current is given by 12 by 4 is 3 amperes. This tells us the circuit will need 3 amperes to operate, which helps us to choose the right wire thickness and the fuse rating. Now coming towards the another important we can say concepts that we have discussed in the today's lecture. That was short to ground in practice. Okay, so what happens when there is a problem of short to ground? A short to ground affects the power side of a circuit. The current flows directly to a ground, bypassing part or all the circuit. This causes no current flow beyond the shorted point. If a wire's insulation is damaged and it touches the vehicle frame, it creates short to ground, leading to high current flow and blowing the fuse. Now, this diagnosing the high resistance value for diagnosing high resistance can be very hard to spot because it may only show up when certain conditions are present, like high temperatures or vibration. The common causes include corrosion, loose terminals, and poor connection. A dim headlight may indicate high resistance in the wiring, reducing the current reaching the bulb. So finally, using the Ohm's law, okay, for troubleshooting, the Ohm's law is useful. The Ohm's law is useful in diagnosing the electrical issues. Knowing any two values, we can allow us to get the third value. This helps us in understanding how much gauge wire is required for a particular application. Take another example. If you know the resistance and current, we can calculate the expected voltage, ensuring the circuit is getting enough power to function. Now, coming on this water wheel analogy, the water wheel analogy shows how voltage drop as the current flows through the resistance. Just as the water loses the energy as it comes from the height, the voltage drops as it moves from the resistors. This concept is similar to car headlight, where each part of the circuit uses some voltage, leaving less for each subsequent component. Now, just coming on to the, you can say, overview of today's lecture, or to some of the concept we have discussed in the today's lecture. We have covered short to ground issues, high resistance, and Ohm's law. Short circuit cause unexpected path to ground, while high resistance slows current flow. Ohm's law helps us to analyze the circuit behavior by understanding how voltage, current, and resistance interact. For example, by applying Ohm's law, we can calculate the correct values for safe and efficient circuit operation, ensuring components like fuses and wires are appropriately rated. So, thank you for today. I hope you have understood the important concepts of today's session. If anybody has particular doubt, please feel free to drop me a mail. And thank you.